So good day everyone, and it's another episode of vectors. Now we would be looking at resolution of vectors. So now from the previous class, I explained how we input our questions onto our calculator based on addition and subtraction of vectors. But today we're looking at resolution of vectors. Now for a vector, and in the last class I talked about vector moving in different direction. Here, moving from this place, you have I, you have J, or you say you have I, you have J. Then if it's going in another direction, let's say another one is coming this way, it can be Z. So now it can be K. So it can be K. So but that's not what we are going to now. What we are going to now, resolution of vectors. Now resolution of vectors is between two or more vectors. Now we'll be looking at a diagram, a graph now in this form. This is the y-axis and this is the x-axis. Here we have, okay, let me put, this is the ax and this is the ay. So here now we have our x, then I, then we have our y, then j. Because now when we are moving into the different directions, I told you in the last class that this one will be I and this one will be j. Now resolution of vectors meaning that we are resolving this vector into a particular direction. Now the resultant vector for this will be A. In which direction? This arrow. Now it's just similar to when we talk about forces, resolution of forces. Now this will be the F, then this is what Newton, then which the Newton the force, let's say 30 Newton, 40 Newton. So the direction of the forces is going to be the resultant force. Then here we also have our resultant vector, which happens to be the resolution of vector. Now let's now go straight without wasting much of our time. Like I said, when we're talking about polar form and angular form, I explained the horizontal components and the vertical components. Now for a resolution of vectors, we have a vertical and an horizontal component which will be resolved into a single component. Now for the horizontal component, we have it to be I, which is giving us A cos theta. I explained this when we're working on polar form and Euler form. Now for the horizontal components, we are having to be x I cos theta. Then for our vertical component, we have it to be y j. Then that will be x j. Then this will now be sin theta. So the angle of direction here, is our theta, which happens to be tan theta is ay over ax, which is axi cos theta, sin theta, y sin theta over ax cos theta. But that's not where we're actually going to, but it's just a light explanation, or to just remove of where we're actually going to. Then if we are resolving to get our A, then we'll be adding our A direction, then ay plus ax. So we look for the magnitude. Now when we are looking for this A signifies the magnitude, then our theta signifies our direction. So we need to get that. Now we'll be looking at 2-3 questions now. We'll be looking at 2-3 questions. Now the first question is this. You're having a vector, you're having your question to be in this form. AX, which is the first vector, the horizontal component of the first vector is 5.1. Then this is it. You're having it this way. Vector 1, here you're having 5.1 and you're having -5. So you're having I and you're having J here. The second one, you're having 2.6 minus 2.6 I, you're having -4.3 J. Now how do we resolve this vector? Now this and this are together, this and this are together, and they said what is the magnitude of the vector sum? What is the magnitude of the vector sum? Meaning that we are looking for the magnitude. Now the best way to solve this and the fastest way to solve this is just to know that this question now, it's actually looking for magnitude, and in resolution of vectors we also make use of the principle of polar form, which happens to be the R angle theta, where this R is our magnitude and this theta is our angle. So please let not forget, it is using the principle of polar form. Now how do we solve this using our calculator, and how do we make it fast? That's what we are going to now. So what you just need to do here is that take your question. Okay, now for the first question, this is how we go about it. Now it's very simple and it's going to be fast. This is how it, so when you come across questions like this is how these are the vectors given, or these are the directions given. Then this A is a vector, this is another vector. So in of this we have I, and X is the I, then Y is the J. X is the I, then Y is the J, from the diagram I drew here. So how do we get the magnitude? From the principle of polar form, R angle theta. So without going too much steps, we are going to solve this. It's basically a two-dimension. It's a two-dimension vector. So what you're just doing that, first of all, change it to vector mode, straight, fast, then input vector 1, which 2-dimension, because you are just having I and J. So the first one, A, is 5.1, so you just press 5.1 equals to, then the next one, -5 equals to. So what are you going to do next? Next thing is to press shift 5, which is shift vector, shift 5. So you want to enter the second data, which is for B, vector B. So you press 2, then you press 2, vector B, then 2-dimension, that's 2. So here you have it. Then you input the second, which is -2.6. I'm trying to be fast as possible so that you can also inculcate that habit. Then -4.3, then you press equals to. So here you've input your, so you just press AC, then you go. Since you are looking for magnitude, vector sum, so you first of all sum the vector. That's what we are doing. Shift 5 to bring out your vector 3, which is A, plus shift 5 again, vector B, which is 4. So you have it like this. So you have your vectors to be 2.5. You have it to be 2.5 I. This is it. You have it to be 2.5 I. The sum of the A plus these 2 points, and bring it this way. The A plus B is 2.5 I plus 2.5 I minus 9.3. you can see that. So that's 2.5i equals to minus 9.3j I. So now, using the principle of a complex number, we did complex number. Using the principle of complex number, here you have it as 2.5i minus 9.3j. then this is the I in your complex form, So now what you just need to do now, you just straight away you take your calculator as fast as possible, just change it to complex 2, then input your question we have 2.5. You are not putting any I again, so you have 2.5 there, then minus 9.3, then this will now be carrying the I in your complex number, which is this. So don't forget, we are changing it to polar form, which is r theta. Now for r theta, you'll be having to be shift, then you pressing shift 2, then this is what we are looking for, 3. So here we have our answer to be 9.6. Sorry, just shifted that. So we have our answer to be 9.63. R equals to 9.63. So when you press SD, it will split it into 9.63 meter. If it's in meter, then your angle is, this is minus 74.95. but when we're doing polar form, you can watch the other episode of polar form. I explained when you have a negative answer, what will you do? You have to subtract it from 360. So you just say 360 minus 74.95. So you have your answer. So your your theta is 295.05 degree. So then your r, which is the magnitude, like I said, the magnitude is 9.63. So that's on that. Now to solve for the second question, now what you just need to do here is just change your question to complex, form, because I said we are dealing with polar form. So change it to complex form, then press, since it's in complex form, then press 6 angle, you press shift this, so you have this angle, then 30 degree. Then your question says sum of the vectors, so you just say plus 8 shift angle 110. So you already have the question. Now sum. So what you just need to do, just press your equal to, this is it, you're equal to. Now this question, you want it to be in polar form. All you just need to do is just press shift complex 3. It's in you want to change your answer to, so this is the answer, straight and fast as that. So you can press your SD, and when you press SD to bring it up, like you can see, the sum of it is 10.80, then angle 76.85, like it has been solved here. So if you want to solve with your hand, there are several means and way of solving it, but not to waste your time, just make use of the calculator as fast as you can. So just try this out and then drop your comments. Other questions will also be in the comment box so that others can also practice it out. So the next question you'll be seeing now, is the question on relating to this aspect I saw. So try as much as possible to also check this out and drop your answers. Don't forget, like, comment, share, and also drop your answers in the comment box. Don't forget to subscribe. Thank you.